if I have a small data set, then this stem and leaf display would probably be sufficient in order for me to notice trends happening in the data. But if I have a larger data set, I may want to make what's called a grouped frequency distribution. And a grouped frequency distribution is a table where I'm going to have some classes. I'll have some class limits, an upper limit and a lower limit. And then from that we'll make what are called class boundaries. And then we will look within each of these classes and find the frequencies for each class. We will construct this thing so that some particular criteria are met. One is that the classes should be of equal width. Another is that the classes should be non-overlapping. In other words, there shouldn't be two classes that any one data value could fit in. Each data value should only have one place to go. And the grouped frequency distribution should be exhaustive. In other words, the entire data set should have somewhere to go in the grouped frequency distribution. Now, the method will be to find the range for the data set. And the range is just the difference between the maximum and the minimum values in the data set. So from our stem and leaf display, we can see that the maximum value is 58 and the minimum value is 21. And that difference then is going to be 37. We take that range and we divide it by the number of classes that we want to have for our grouped frequency distribution. And there's no hard and fast rule about how many classes you should have in a grouped frequency distribution, but you do want to have between 5 and 20. If you don't have enough data values for 5 classes, then you probably don't need to construct a grouped frequency distribution. A stem and leaf display would probably be sufficient, as we can see with such a small data set like this. We don't want more than 20 because we don't want the table to be so large that we can't see trends in the data. We don't want to have the data values spread out too thin between classes, so we don't want too many classes, but then again we don't want them grouped in too large of groups, so we don't want to have too few classes. Now, since we have a small data set here, let's just go with the minimum number of classes and just say, let's take the range and divide it by 5. So the whole idea here is to divide the range by the number of classes, and we're choosing to have 5 classes. So this range, 37, divided by 5, will give me 7.4. Now, this is going to give me the class width. And in order to find that class width, we always round up, no matter what we get from this calculation. So in this case, since our data values are whole numbers, we're going to round up to the nearest whole number. So round up to the next whole number in this case. If our data set had been tenths place data values, we would have rounded up to the next tenth. So you round up according to the place value significance of your data values. So our class width will be 8. So what we do is we start with the minimum value. So our lower limit for the first class is the minimum value. So we take that minimum value, which was 21, and we add the width to get the lower limit for the next class, 29. And then we add it again to get the lower limit for the next class, 37. And we were going to have 5 classes, so we're going to do this until we have 5 lower limits. So 37 and 8 is 45, and 45 and 8 is 53. The next thing that we're going to do is we're going to subtract 1 from each lower limit to find the previous upper limit. So I'll take 29 and subtract 1 and get the previous upper limit, 28. Subtract 1 from 37 and I'll get 36. Subtract 1 from 45 and I'll get 44. And the thing that I might notice happening then too here is that each of these differs by 8. So if I just add 8 to 44, I get 52, and add 8 to 52 and I'll get 60. So this is how we get our class limits. The next thing that we would want to find would be our class boundaries. The class boundaries we find by going halfway between each of these upper limits and lower limits for the next class. So in other words, between 28 and 29, I'd have 28 and a half, halfway between. So just add them together and divide by 2. But I would also, since I need the classes to be of equal width, I'll need to spread it out the same on either side. So if I'm adding 20.5 to 28 on the upper limit of this first class, I'll need to subtract 0.5 from 21 on the lower limit. So I'll have 20.5 to 28.5 for my boundaries. 28.5 to 36.5. 36.5 to 44.5. 44.5 to 52.5. 52.5 to 60.5. So these are my class boundaries. To find the frequencies, I'll go into the stem and leaf display and look at this first class, 21 to 28. Well, there were 4 data values. 29 to 36, there was actually 1. 37 to 44, there are 1, 2, 3, 4, 5, 6, 7, 8 data values in that group. 45 to 52, there's only 1. And 53 to 60, there are 1, 2, 3, 4, 5, 6. And then I'd want to add this up and make sure it adds to the number of data values that I have in the data set. There's 4 and 1 is 5, and 8 is 13, and 1 is 14, and 6 is 20, and we have 5 rows and 4 columns here, so 20 data values. So here is our grouped frequency distribution.